welcome to another Intermediate Algebra video. Today we begin to look at graphing. Mostly we'll be looking at graphing linear equations. We'll get a quick introduction in this unit to a few other types, but just barely. Primarily we're focusing on linear equations. So the objectives for this video are plotting ordered pairs, determining whether an ordered pair of numbers is a solution to an equation with two variables, and identifying linear equations versus nonlinear equations. Our first objective, plotting ordered pairs. Okay, so a few pieces of the graph that we're going to look at. I have kind of the important pieces highlighted on here. The first one is the x-axis. You can see the x-axis over here. And then our y-axis up here at the top. So our blue line is the x-axis, red line is the y-axis. These are just some features of the graph. Where those things intersect in the middle is the origin. As an ordered pair, the origin is 0, 0. Means no x movement and no y movement have happened. You're at this location. And then the quadrants are labeled. Quadrant 1 up here on the top right, quadrant 2, top left, quadrant 3, bottom left, and quadrant 4, bottom right. Identifying the quadrants isn't something that we'll do a whole lot of. I just want you to have the names for them. If you were to continue on, you'd see a little bit more maybe of using the quadrant names. They might be referred to throughout, but it's not a huge matter of concern. We will identify them, but it's not a huge issue. Okay, so plotting an ordered pair. This is an example of an ordered pair, 2, 5, ordered pair. The first number is your x-coordinate, and the x-coordinate tells you, it's a movement along the x-axis, it tells you how many units to go left or right. So a positive number tells you to move from the origin to the right that many units. And then a negative number tells you to go backwards, essentially, to the left. The second number in the ordered pair, first number, comma, second number. The second number is the y-coordinate. And you can guess what this stands for. Just as x is your left or right movement along the x-axis, y is your up or down movement on the y-axis. So a positive number tells you you're moving up from the origin or the x-axis, and a negative number tells you to move down. So for example, this ordered pair, 2, 5, 2, we started the origin, we go 2 units in the positive direction to the right, and then 5 units up, 1, 2, 3, 4, 5, and we plot our ordered pair 2, 5. So this is how you plot an ordered pair. Okay. All right, let's look at a couple examples. So for this problem, let's plot or graph the points. You might see it labeled either way, plot or graph, and then state which quadrant the point falls in. Go ahead, pause the video, practice. You can plot these on this graph, and then we'll go through it together in a moment. Go ahead, when you put the point on the graph, put the letter with it, so label what that point is. If you wanted to, you could either write the ordered pair itself or the letter, but let's go with the letter for this one. Okay, so let's see what you got. Our first ordered pair, let's keep going in blue here. Our first ordered pair is 2, 4. So from the origin, we're going 2 in the positive x direction and then 4 in the positive y direction. There's our ordered pair, point A. Point B is at -3, 4. So backwards 3, and then up 4. 1, 2, 3, 4. Our third point, C, is -2, -1, so we'll go in the negative direction, 2 for x, negative direction 1 for y. This is point C. We'll label which quadrant they're in at the end when we have them all on there. Point D is 3, -4, so from the origin, 3 in the positive x direction, 3 in the negative y direction. Don't be deceived by where the number sits. Make sure you're counting 1, 2, 3 units down. Oh, this should be E. Whoops. Point E, 0, 2. So this means there's not an x movement left or right, but we go up 2. E. And the last one, F, 0, 0. We don't move left or right, and we don't move up or down. Okay. All right, now let's label where each of these falls. The first point, point A, falls in quadrant 1. The second point, B, in quadrant 2. The third, point C, is in quadrant 3. Point D is in quadrant 4. Point E, if it doesn't specifically fall in one of the 4 locations, then it's falling on an axis, so you can label it as such. Point E is on the y-axis. Oh, on top of me. And then point F is at the origin. So you could say origin, or you could say x-axis and y-axis. So this is the first objective, plotting ordered pairs. This was just plotting a set of random ordered pairs. These don't connect in any sort of line. So for this example, if you did connect them, you really shouldn't have. We weren't told that this was a line. We were just told that these are some ordered pairs for the graph. In general, where we're going is connecting these to make a line because we're graphing linear equations. But for the time being, these are just ordered pairs. All right. Let's continue on. Okay, so our next problem is seeing if an ordered pair is a solution, so the second objective. So this is what the problem would look like. A linear equation looks just like this, 3x plus 2y equals 12. It has an x and a y, both to the first power. We'll get to that definition though. And so here are the steps to determining if an ordered pair is a solution to this equation. So what we can do first is plug in x and y, meaning the ordered pair. Then we can evaluate the left and the right independently. If we get a true statement, then yes, it is a solution. If we get a false statement, it's not a solution. So essentially what we're doing is we're seeing if the ordered pair that's given is a point somewhere on the line. So maybe the line looks something like this. We don't exactly know. We haven't graphed it yet. But we're seeing if 0, 6 is a point on that line. Maybe it is, maybe it isn't. And this is how we can figure that out. Plug in x and y, evaluate the left and the right, and then see if we get a true or a false statement. Okay, so 0, 6, let's plug that in. 0, 6 is our x and y. 0 is our x, 6 is our y. So we'll plug these in. 3 times 0 plus 2 times 6 equals 12. And we're seeing if this is a true statement. So evaluate the left and the right independently. 3 times 0 is 0, plus 2 times 6 is 12. 0 plus 12 is 12. That's the left. And on the right, there's really nothing to evaluate. We just have the number. We get 12 equals 12. So we plugged in, we evaluated the left and the right, and now we assess. Did we get a true or a false statement? 12 equals 12 is a true statement. So yes, this is a solution. Yes. 0, 6 is a solution. So obviously then this line is not what the graph would look like. Now in this example, we were looking for everything to work itself out to be 12 because that's what the equation was equal to. But it might be the case that some of the variables, one of the variables is on the other side, and so we would need to evaluate independently. So that's why this third step doesn't necessarily say is it equal to 12 or equal to whatever number you have. We just evaluate if we get a true or a false statement. Okay, so that's the second objective. Let's go ahead and practice. So pause the video, go ahead and using this same given equation, evaluate if these two ordered pairs separately are points on this line, if they're solutions to this equation. Okay, so you should have practiced these two. Let's plug them in and see what we get. For the first one, our ordered pair, -4 is x, 0 is y. So we plug in 3 times -4 plus 2 times 0. Step 1, plug in. Step 2, evaluate the left and the right. On the left, we have -12 plus 0. We get a statement of -12 equals 12, which is false. So, to answer the question, is -40 a solution? No. -40 is not a solution. We're looking for true statements for this to be a solution. So this ordered pair doesn't fall anywhere on the line of this linear equation. The second one is 2, 3. So we'll plug in for x and for y. 3 times 2 plus 2 times 3 equals 12. We have 6 plus 6. We get 12 equals 12, which is a true statement. So yes, 2, 3 is a solution. So that's our second objective, determining if an ordered pair is a solution to an equation with two variables, meaning x and y. All right, continuing on. Okay, so let's get the definition of a linear equation, since that's what we're going to see throughout most of this unit. A linear equation, in the simplest sense, is a straight line. So when we're graphing it, it's a straight line. Can be any type of straight line, can be have an incline to it, a decline, horizontal, vertical, all different kinds. And the true definition of a linear equation is an equation is considered linear if it can be written in this form: ax plus by equals c. Some notes about this equation. In this format, a, b, and c, they just represent numbers. Any numbers. They can be positive numbers, they can be negative numbers, they can be 0. We'll see the examples where that is the case in a later video, but they can be any type of number: decimal, fraction, negative, positive. That's all it takes for an equation to be linear. If you can get it in this format, then it is linear. So let's look at a couple examples. The first one, is this equation linear? So to make that decision, we have to decide, can we take this equation and modify it to look like this format: ax plus by equals c. So the way it's sitting, it's not currently reflecting this format, ax plus by equals c, but the question is, can we get it there? All you have to do is answer yes or no for something like this, and you don't have to get it in this format, just decide, can you? So, could we get it to look like that? For this one, I am going to make it look like that. To get it in this format, all we would have to do is subtract 2x from each side. Then we have an equation, -2x plus y equals -2. ax, so -2 is the a in this scenario, plus by, if there's not a number multiplying by the y, what is that value? It's a 1, is equal to c, a number, -2. So, to answer the question, is this equation linear? We can get it in this format, so yes. Yes. To compare it, the second equation, is this one linear? Y equals 1/2 x squared. There's a couple things that are different from our standard form of the linear equation. We definitely have an x and a y, which are things that would need to be there. And you could certainly say that you have an a, b, and a c. The c in this case, if you're not seeing it, is sort of like a ghost plus 0, which is fine. The a, the thing attached to the x squared, is a 1/2, and we could bring this over so that we would have ax and by equals c, but the problem, the thing that makes it not a linear equation, is this second power on the x. So what's important for an equation to be linear is that you have potentially both x and y, maybe just one, but that they're both raised to the first power. If I don't see an exponent on these variables, then it's assumed to be a 1. So when we see an x squared here, we know this is not a linear equation. So the 0 doesn't help us in any way. The reason that this is not a linear equation, is that the power on the x is not what we need it to be of a 1, but it's a 2. That causes the graph to look different. The graph of this would not be a straight line. Okay. Continuing on. All right, so now we're going to take a look at the calculator. And in order for us to graph things on the calculator using our TI-84, if you have a TI-83, that's fine. Any version of the 84 is okay. For us to see the graph on the calculator, it has to be in this very specific form. It has to be y equals blah, 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 blah. Everything else has to be on the other side of the equation. So essentially, it needs to be solved for y. Needs to be solved for y. Okay, so let's see an example where we use the calculator. Okay, so here's what we're going to do. Determine if the equation is linear. We're going to do so by looking at the calculator. If so, find 3 points, graph the line, determine which quadrant the points are in, and then verify on the calculator. Okay, so let's take a look at this one on the calculator. Actually, we're going to determine if it's linear from that definition. So could we manipulate this equation to have ax plus by equals c? The answer is yes. We could, if we wanted to, subtract 2x from each side and get negative 2x plus y equals negative 2. This could be written in that format. This is a linear equation. In fact, I believe, yeah, this is the example that we just saw. So this can be written this way. We don't have to write it that way. So first question, is this linear? Yes, it is linear. Okay, if it is, then we're going to do a whole mess of things. Find 3 points, graph the line, determine which quadrant those points are in, and verify on the calculator. Verifying on the calculator will be the last thing we look at. So how can we find points? Well, we know what they should look like. They should be an ordered pair, something in parentheses, x, comma, y. But we don't have any information on what those might be for this equation. So what we're going to do is kind of build a little chart for ourselves. And we're going to find some ordered pairs. At this stage, you might have some ideas on what to do. You might be wanting to graph a specific way. At this stage, all we know about is finding these random ordered pairs. So it's our choice if we want to plug in for x or if we want to plug in for y. You could do a little of both if you want to. But for this equation, which do you think it's easier to plug in for? For me, I think it's easier to plug numbers in for x. If we plug numbers in for x, we're going to multiply and subtract to get a corresponding y value. If we plugged in for y, we would have to add 2 to both sides and then divide by 2. So truthfully, it's 2 steps either way, but it looks a little easier if everything is on one side. So I'm going to go that route. Let's plug in a few different numbers. Let's get 4 ordered pairs and plot those. So I'm just going to pick numbers for x. I'm going to choose -1, 0, 1, 2. You could pick totally random numbers. You can pick 100, 300, 500. It's up to you. Forgive that line. It's still -1 and 0. But these are the values I've chosen. So let's plug them in and see what we get. So if I plug in -1 for x, what do I get for y? 2 times -1 is -2, minus 2 is -4. So there's our first ordered pair. Okay, let's plug in 0. If we plug in 0, what do we get? 0 minus 2, which is, not showing, -2. Okay, so there's our second ordered pair. First ordered pair, -1, -4. Second, 0, -2. Third ordered pair, if we plug in, let's fit it up here. If we plug in 1 for x, we get 2 minus 2, which is 0. So our next ordered pair, 1, 0. And our last, if we plug in 2, we get 4 minus 2, which is 2. As an ordered pair, x is 2. The y we got when we solved was 2. Okay, so we have 4 ordered pairs. The question said find 3. Look at that. We don't even need the last one. Definitely done there. Okay, the next thing is graph the line. So let's sketch and graph this line. The highest values, let's see, my x's are -1, 2. My y's go all the way down to -4. You can draw tick marks everywhere if you want to. And then let's plot these ordered pairs. Let's do this in red. So the first ordered pair, -1, -4. Come down for this one in. Second ordered pair, 0, so we don't go anywhere left or right, down 2, -2. All right, third ordered pair is 1, 0. 1, 0, so over 1, up and down, none. And then the fourth point that we found, 2, 2. Just as we expected, this is linear, so they connect to form a line. And in this case, you can connect the points. So there's our next step. We determined that it was a linear equation, then we found 4 points. We graphed the line. Next, we're going to determine which quadrant the points that we found are in. Let's just do it for all 4. Blue. And then we'll verify on the calculator. Okay, so here are the ordered pairs. Let's label their quadrants. This first point, -1, -4, fell in quadrant 3. The second point, 0, -2, fell on the y-axis. The third point, 1, 0, fell on the x-axis. And the last point, 2, 2, fell in quadrant 1. Now, if you chose different x values to plug in, you may have gotten different ordered pairs, and those ordered pairs may have fallen in different places. We can definitely see from this graph that you would never have any points falling in quadrant 2, so none of your answers should say quadrant 2, but the rest are possible, depending on the points that you chose. If you had chosen only 3, that's fine. That's all the question asked for. I accidentally did a 4th, but that's okay. And if your picture looks a little bit different, if it's slightly skewed left or right, that's okay. But the general feature of from left to right, the graph is going up. That should be the same. All right, so we've determined the quadrants. Now let's take a look at the calculator. Last thing, verifying the calculator. So remember, in order to look at it on the calculator, it needs to be in this format, y equals 2x minus 2. And it is, so now we can look at it on the calculator. So if you have your TI-84 or 83, go ahead and take that out, and let's take a look. So once you turn the calculator on, click the on button at the bottom. In order to look at this on the calculator, go all the way up to the top left-hand corner of the calculator and click the Y equals button. This will open up a menu. Now, you see a whole bunch of Y equals set up, Y1, Y2. These are all just if you wanted to type in multiple equations at the same time. We're just going to type in one. So it should be ready for you to type something in this first line. And if you clicked up or down, you can see it would let you type into different lines. It's fine. This calculator has colored lines, so if you wanted to see it in a red line, you could type it in that second, the Y2 line, just means the second equation. But you can always default to keeping it on that first one. That's not a problem. Okay, so let's type in this equation. Our equation is 2x plus 2, so you can hit the 2. X is on this button here at the top. It has a handful of variables on it. Because we are in the standard mode, when you click this button or when you hit this button, it's going to put X in there. The other variables are for different modes, nothing that we'll see in this course. 2x and then minus. This is an important point on the calculator. You know that there's not a difference between minus and negative, that they ultimately mean the same thing. But the calculator doesn't interpret it that way. So there is subtraction happening here. The calculator needs to see subtraction. If you wrote negative there, it would say error when you went to look at the graph. And then minus, what do we have? 2. Okay. All right, so now we can look at the graph. So if you go up to the top along your top 5 buttons, all the way on the right is the graph button. Click that. The screen will come up. And you should see it graph slowly, quickly, depends on your calculator. So there is the equation, our linear equation graphed. And so verifying it is looking at the calculator and making sure that what you have on your drawn version looks the same. And it does, so that verifies for us. Again, the skew is a little bit off, but when we draw something by hand, it's never going to be perfect. It's also important to note that the calculator is set to a specific window. So this is the default window. It's showing 10 in the negative x direction, 10 in the positive x, 10 in the negative y, 10 in the positive y. And you can change that to get a different view on the graph. Let's go ahead and do that just to get some practice. So if you go up to that top 5 row and you click the window button, and if this is not what you're seeing, then in the window button, we should be able to fix it. This is the standard setup for your window. It says the x minimum is negative 10, meaning the farthest thing to the left that you see is negative 10. X max, farthest thing to the right that you see is positive 10. The scale, this just tells you how often there's a tick mark. So 1, every 1 unit you'll see a tick mark. Then the y, the lowest value you see is negative 10. The highest value you see is positive 10. Again, the scale is 1, and you don't have to worry about the rest of them. So let's change this instead of negative 10 to 10. Let's say the lowest we want to see is negative 5. You can hit down or enter. And the highest x we want to see is positive 5. So all we're doing is taking the window and shrinking it. Imagine when you're looking at a picture on your cell phone, you zoom in on things. We're just, you know, stretch the screen to zoom in. Or press out to zoom out. So we're just doing that essentially. All right, so let's hit the graph button again. It'll redraw. And you can see that the picture looks a little bit different. It looks like it's tilted a little bit more, but it's the same information. The general features are still the same. You can see that it's intersecting at 0, -2, and at 1, 0. That's important, some of the ordered pairs that we have. And that from left to right, it's going up. That's important. You should see that same type of feature in your graph. Those are really the big key features. In general, if it's a little off, that's okay. But the standard window is -10 to 10. Just know that you can modify that, you can manipulate it. So I'm going to go back to this and change it back to the standard, -10 as your minimum, 10 as your maximum, scale of 1, and -10 to 10 for the y's, scale of 1. Okay. Another cool feature that's on this calculator is looking at the table. So if you see in blue above the graph key, it says table. You can get into any of these blue options on the calculator by first hitting the second key. So if we hit second and then the graph key, it'll take us to a table. And this table shows us, plugging in all these different values for x, what the corresponding y value is. So this gives us a whole bunch of ordered pairs. Now it started at 0. You can click up and down to see different values on this table. And it's the same thing. You can look at the table settings. The table settings exist in the blue above the window key. So if we hit second and then window, we get into the table settings. And the two pieces of information that you have to worry about, it says table start currently at 3. That's where my cursor was at the moment. -3, sorry. And then the change in the table, this little triangle means change in. So it's going to show you every x going up by 1. So 0, 1, 2, 3, 4. If you change that to 0.5, it'll go 0, 0.5, 1, 1.5, 2, 2.5, 3, and so on. So you also have the ability to change that. If, for instance, you didn't want to start close to 0, maybe the information you're looking at starts at 100, that's where the first important piece of information is, you can click, all right, table start at 100, and then go back into the table by clicking second, and then the graph key. And this will show you, okay, if x is 100, what's the corresponding y value? All just points on this graph, all points that work for this equation, but points that are difficult to see outside of the graph. I also want to point out to you, if we go back to this graph, slowly but surely, our graph is kind of focused around the origin. It's pretty close. And in general, you can expect most of the graphs to kind of fall within that, within this window. But just know that just because you type in an equation and then hit graph, just because you don't see it, it doesn't mean it's not there. If that line existed somewhere to the right and a little bit further down, maybe the line exists right here and you're not seeing it because your window's on the wrong spot. So keep that in mind. You may need to mess with the window down the road. I wouldn't expect it in this class, but it is something that could definitely come up. All right, any other important calculator features? Let's go back to the y equals screen. I just want to show you one more thing here that's important. I can't tell you how often I see issues with typing in the negative versus minus. So let's say, for example, that the graph we wanted to look at was y equals -2x. Different graph, different problem. I just want to show you this in the calculator. If I click minus instead of negative, and then 2, and then x, and then go to the graph to see this, it says error, you've typed in minus instead of negative. For whatever reason, the calculator does not know that that means the same thing. So you can hit quit, go back to this y equals screen. I'm just going to clear it and retype it. Instead, type minus, or sorry, not minus, negative, there's the issue, -2x. And you can see if I kind of compare on that next line, if I type subtraction 2x, it looks slightly different. Pretty much the same thing, but you can see that it's a little bit smaller and a little bit higher. So that's one clue if something goes wrong. If we type negative 2x in there instead and hit graph, it'll give us the right thing. It'll allow us to see it, it'll put the line in there, and then the calculator sees everything correctly. Okay, so this is a way for you to verify that everything that you've done is correct. Verify that your work done by hand, that your points are accurate. You can see what quadrant they're falling in, that your graph is accurate. And keep in mind that it's never going to look quite perfect because you're drawing it and the calculator is using a specific window to show everything to you. All right. And if you wanted to see more than one at a time, you definitely can. You can type in that equation we just looked at compared with the one that we already graphed, and it'll show you more than one at the same time. There's the two lines and the two different colors. If you don't have the colored version, you're just seeing both lines, and that's fine. Okay, so let's do a practice problem with these same directions. Second quit gets us out of that y equals screen and back to our standard screen to be able to type things in. All right. Okay, so here's your practice problem. Go ahead and pause the video, go through the same process. First, determine if this given equation is linear. If it is, find 3 points. 3 is enough, you don't have to do 4. Graph the line by hand, determine which quadrant those 3 points are in, and then verify it on the calculator. Okay, so you should have practiced at this point. I know that the calculator can do all of the things I'm asking you to do, but you need to do them by hand to be prepared for what's coming in the future. Okay, so the first consideration, is this equation linear? Can it be written in the form ax plus by equals c? And it definitely can. In fact, it's already written in that format. Okay, then our next consideration, so let's write that down. Yes, it's linear. Okay, if so, find 3 points. So I'm going to make a little chart. For this equation, is it easier to plug in for x or y? Truthfully, it's about the same amount of work either way. You could choose to plug in for both. You could choose to continue plugging in for only one and not the other. It would be up to you. So I'm going to plug in, let's go -1, 0, and 1 for x and see what we get. You don't always have to pick these numbers. You could pick 0, 1, 2. You could pick 3, 4, 5. You could pick 2, 4, 8. Whatever you want to do. It doesn't matter. Just know that you then have to take those values and graph them. Okay, so if x equals -1, let's see what we get for y, corresponding y value. We have 4 times -1 plus 4y equals 4. And we're solving for y. We're looking for the other part of this ordered pair. -4 plus 4y equals 4. Add 4 to both sides. 4y equals 8. Divide by 4. Y equals 2. All right, so I have room for this graph. I'm going to do the other two up here. What if x is 0? What's our corresponding y value if x is 0? Plug it in. Let's see what we get. 4 times 0 plus 4y equals 4. This is 0. And the only thing we need to do, divide by 4. We get y equals 1. And then our last point, what if x is 1? Our last, at least in my example, you could have had different points. When x is 1, 4 times 1. Subtract 4 from both sides. We get 4y equals 0. Let's pull this up and keep going. Now you might think, all right, well, this isn't possible, but just keep going through the process. Next thing would be divide both sides by 4. What's 0 divided by 4? If you're not remembering or you don't trust it, type it in the calculator. 0 divided by 4, 0. So we do get an answer. We have an ordered pair. All right, our 3 ordered pairs. So we determined it's linear. We found 3 points. Now let's graph the line. plot these ordered pairs, -1. I'll do this in red again. -1, 2. First ordered pair. Second ordered pair, 0, 1. 0 left to right, up 1. And third ordered pair, 1, 0. Now, we expect this to be a line because we already decided it was a linear equation. So when my 3 points line up, I know something most likely went right. Connect, there's our line. And then the last step is to verify on the calculator. Verify on the calculator. Okay, so in order to type this into the calculator, we need this to be in the form of the equation y equals everything else. We don't have that. How do we get there? We'll have to solve for y. So I'm going to erase just this stuff so we have some space on here. And let's solve for y. White, okay, 4x plus 4y equals 4. If we want y by itself, undo everything happening to it. Subtract 4x from both sides. And then divide everything by 4. Now you have the choice of dividing everything or each individual piece by 4. For this one, dividing each individual piece will be more helpful. We get y equals -4 divided by 4, -1x, or just -x. 4 divided by 4, 1. I often have students for this problem make this their first step, solve for y, and then find all the ordered pairs from this equation. That's fine. This equation is the same thing as this standard linear equation. It's just in a different format. So if you did it that way, that's perfectly fine. Okay, before we verify in the calculator, I realized I skipped this third or fourth consideration. Determine which quadrant the points are in. So let's add that in blue before we actually look at the calculator again. This first ordered pair, -1, 2, is in quadrant 2. The next one, 0, 1, is on the y-axis. And the last one, 1, 0, is on the x-axis. Just practice of locating where these are. Okay, so now let's look at this on the calculator. So on the calculator, clear this out, it doesn't matter. Just go to the y equals screen and type in, we have -1 or without 1, x plus 1. Hit graph, and our line looks similar. Again, the tilt might be off a little bit, but the same general features exist. We can see at least two of the ordered pairs quite easily, 0, 1 and 1, 0. They're both definitely showing up on our graph. From left to right, it's going down, so that's definitely a good sign. So we found these, and we verified on the calculator. Okay. Again, if you wanted to play around with zooming in on this, you can hit Window and change the features, or you can just click the zoom button and tell it that you want to zoom in. Click the second command, it'll zoom in a little bit more. Oh, it's asking where do we want to zoom around. So this is kind of like when you zoom in on your phone. You put your finger wherever you want to zoom in and pick that specific location. You can click zoom in and it'll click enter, it'll zoom in for you. Come a little bit closer. Now this looks a little bit more like our picture, but that doesn't necessarily matter. It's just verifying, and that's really all there is. Okay. All right. So to summarize, everything that we looked at in this video kind of was an introduction to graphing. So we plotted ordered pairs, and we looked at what it means for something to be a linear equation, and we also figured out how to test if specific ordered pairs work as points for those lines. So hold on to this information. If you have any concerns, feel free to email me. In the next video, we'll continue on our journey of graphing linear equations.